Hey there, and welcome. Today, we're going to decode something that's literally all around us, in pretty much everything we touch and taste. We're talking about the pH scale. It's like this hidden language that determines the tang of a lemon or the slippery feel of soap. So, let's break it down. Have you ever really thought about why a lemon tastes so incredibly sharp? Or why soap feels the way it does on your hands? So slippery? Well, believe it or not, those feelings aren't random. They're actually clues, and the secret behind them is all about a simple number. So, first things first, what in the world is the pH scale? Well, it's basically a simple chart that runs from 0 all the way to 14, and it's designed to measure one thing: how acidic or basic something is. You can think of it as a spectrum for an item's chemical personality. Okay, so what does pH even stand for? It actually means potential of hydrogen. And at its core, the scale is it's just counting something. It's counting the concentration of hydrogen ions, those tiny H+ particles that are floating around in a solution. And you know what? The rule here is surprisingly simple. The more of those hydrogen ions you've got packed in there, the more acidic the substance is. And you guessed it, the fewer you have, the more basic or alkaline it becomes. It's like a constant chemical tug of war. Which, of course, brings us to our two main players: acids and bases. They hang out on opposite ends of the scale, and they have completely different personalities. Let's start by taking a look at the acids. All right, so on the low end of the scale, everything from 0 up to 6, that's acid territory. These are the things we usually think of as having a sharp, sour taste. And as a lot of us know, the stronger acids can be pretty corrosive. And you definitely don't have to go to a chemistry lab to find these things. I mean, your own stomach is producing this incredibly strong acid right now with a pH of about 1. The lemon juice in your fridge, that's around a 2. And the vinegar you put on salads is right there at a 3. They're everywhere. So what do acids actually do on a chemical level? It's simple. They're givers. When you put an acid in water, its whole job is to release or donate its hydrogen ions to the body. Now let's jump to the other end of the spectrum. Way up high, from 8 to 14, we find the bases. You might also hear them called alkaline substances. Their trademark characteristics: usually a bitter taste and that really distinct slippery feel. And just like acids, bases are all over our homes. The bleach under your sink, that's a super strong base, way up at a 13. The soap you wash your hands with is a bit milder, sitting around a 9, and the baking soda in your cabinet is just a little over neutral, at a pH of 8. And hey, if acids are the givers, then it only makes sense that bases are the takers. Their chemical job is the complete opposite of an acid's. They accept or scoop up all those free-floating hydrogen ions in a solution. It's this perfect opposition that makes them so important. So let's just put it all side by side for a second. You've got acids, low pH, sour taste, and they donate hydrogen ions. And on the other team, you've got bases: high pH, bitter taste, slippery feel, and they accept those same ions. A perfect chemical face-off. But wait, what about the middle? What about that number 7, sitting right in the center? Well, at a pH of exactly 7, we have perfect neutrality. This is the home of pure water, where everything is in perfect balance. It really is the Switzerland of the chemical world. So the next logical question is, how do we actually measure pH? I mean, we can't just look at a glass of water and know its number. But luckily, chemists have a couple of really cool, simple tools to make the invisible visible. The classic method you probably remember from school is litmus paper. It's just a simple strip that gives you a straight answer. It turns red if you dip it in an acid, and it turns blue in a base. Simple. But if you want more detail, you can use a universal indicator. It's this liquid that changes into a whole rainbow of colors, and each color matches up with a specific pH number. Pretty cool, huh? Okay, so this is all fascinating chemistry, for sure. But why should you actually care about any of this? Well, it turns out pH isn't just a number in a textbook. It's an absolutely critical factor that affects almost every single part of our world and even our own bodies. For example, farmers are obsessed with the pH of their soil, because if it's too acidic or too basic, plants just can't absorb the nutrients they need to grow. Industry relies on it for making everything from powerful cleaners to life-saving medicines. And maybe most importantly, our own bodies are in this constant, really delicate balancing act with pH. Just think about this one number, 7.4. That is the ideal pH for human blood. If our blood's pH changes even slightly from that very, very narrow range, our internal systems start to fail. It is an absolutely vital sign for our survival. Now, before we wrap this up, I want to let you in on the biggest and maybe most powerful secret of the pH scale. You might think that moving from a pH of, say, 3 down to a pH of 2 is just a small step, but you'd be mistaken. There's a hidden power in these numbers. Let's actually put this to the test. So, we know your stomach acid is a pH of 1 and vinegar is a pH of 3. That's a difference of 2 steps on the scale, right? So, how much more acidic is your stomach? Is it twice as acidic? Maybe 4 times? Take a guess.
The answer is 100 times. Yeah, not 2 times, not 10 times, 100 times more acidic. It's a massive difference, and it totally reveals the true power of this scale.
And here's why. The pH scale is what we call logarithmic. That's the secret. Every single number you move on the scale represents a times 10-fold change. So going from a pH of 3 to 2 means it's 10 times more acidic. And going from 2 to 1 is another 10 times more. So 10 times 10, that's 100. Mind-blowing, right? So let's bring it all together one last time. Anything below 7, you've got your acids, like lemon juice and vinegar. Right at 7, you've got perfect neutrality with pure water. And everything above 7 is basic or alkaline, like your soap and bleach. Simple, powerful, and now you know the hidden 10-fold secret of the scale. And there you have it, the pH scale, totally demystified. It's just a simple number with a really powerful secret. It governs how we grow food, how our bodies work, and so much more. So now that you know the code, start looking around. What's the pH of your world?